In this presentation we are going to see about pseudo op and machine op in assembly language. So in previous lectures on that we have seen assembled mnemonic program. Okay, so here by using this assembly language, we are going to make some changes. In this. Okay, what are the changes are we will see. Assembly mnemonic program we have seen in last presentations, like looping, non-looping, address modification using instruction as data, address modification using registers, index register, and looping method. This all and all we have seen by using assembled mnemonic program. Okay, in this way we have handled. But here we are going to use assembly language, exact assembly language. We are going to use by using pseudo ops, and machine ops. Okay, so by using these two things we are going to give the instructions to the assemblers. So the assemblers is going to receive the instructions, and it is going to convert the instruction in machine understandable language. This is only going to happen here. Okay, what is the difference between assembled mnemonic and assembled language, which means assembly language? So assembled mnemonic program we have handled with a relative address, right? Relative address plus base register value plus if you have index value, then index register value that we will add here. So index register. Okay, by adding these three we will get absolute address, right? We will get absolute address to take the data, to get the data. Okay, so by using the absolute address we are going to find the data where it has been stored in the core memory. But here we are not going to do like this. We are not going to handle by a relative address. Okay, relative address we are not going to take here. So by instead of that we are going to use pseudo ops. We are going to use. Okay, by using the pseudo ops we are directing the assemblers. Okay, we are directing the assembler to what to do. Okay, so assembler is a piece of software. We know that there is a system software, okay, which will convert the assembly language into machine understandable language, that is binary numbers. Okay, this we have now. So by using pseudo op we are going to write the instruction for the given problem. Okay, that only we are going to do that. So before going to that we have to understand what is pseudo op and what is machine op. Then only we can write the instructions in this pattern. Okay, so here I have pseudo op. So in this presentation we are going to cover these 8 pseudo ops. Okay, what it is, what its purpose for. Okay, and on left of your screen I have definition of assembly language and the basic features of assembly language and its definitions, and middle of your screen I have pseudo ops, 8 pseudo ops, and machine op also I have, but in this presentation we are not going to cover this. And here we have pseudo ops descriptions, so what it is, some examples also I have given here. Okay, that and all we will see. Okay, we will start now. So first we will see the definition of assembly language. So we are familiar with this, we know what is assembly language. It is a low level programming language that allows user to write a programs using mnemonics. So mnemonics only we are going to use, right? Mnemonics we know, we have studied also. For example, L is a mnemonic for load, A is a mnemonic to add. Okay, and BC is a mnemonic BC stands for branch on condition. Okay, these are the mnemonics. By using the mnemonics we can write the instructions in the assembly language. We know that, right? So next we have the basic features of an assembly language. So we have three basic features. First one is mnemonic operation codes, next one is symbolic operation codes, next one is data declaration. Okay, first we will see about mnemonic operation codes. So mnemonic operation codes is nothing. We know that when we are writing something, for example L 2, 904. Okay, so inside the bracket we have index register value 0 and 1 as a base. 1 we are giving as a base register number. Okay, so by adding these all things we will get the data, and the data will be stored into the data will be loaded into the register 2. This is the meaning of this. So mnemonic operation codes means this one, that L is there, that L is said to be mnemonic code. Okay, so it will tell which it will tell to the assembler what operation we have to do with this register and this location data. That is it to be mnemonic operation codes. So what we have to perform, which operation we have to perform, that we are telling to the assembler. Okay, so next we have symbolic operands. What is symbolic operands? So we have studied C, C++. Yes, studied C, C++. In C, C++ and all, what we will do, if we want to declare any variable, we will use integer data type. Okay, according to the data type we will use. So what value we are going to declare, according to that we will take the data types. So example, int a is equal to 4. I am going to declare this value, right? So we will declare this in C or C++ like this. But you see, if it is assembly language, we are going to handle in different way. How we are going to handle? See, instead of what things we require to declare a variable, the value we need, the constant value which we are going to declare we need, and variable we need, and also data type we need, right? So for this, memory allocation will be there. For integer there will be 2 bytes of memory will be allocated. We are comparing with C or C++. According to the machine, it will allocate 2 bytes or 4 bytes for integer data type, right? Here in assembly language we have to declare a variable, which means we are going to declare a value. The same 4 I am going to declare in assembly language. In which way we will see. See what we need. First we need variable, right? So variable I am taking as some word. For example, here I am writing FOU. This is a word I am going to store. In this word I am going to store the value 4. So FOU, that is a variable name, and this is a constant, right? So I am using here the pseudo op, that is define constant. Define constant is a pseudo op. Okay, and we are going to tell the machine, tell the assembler that I want one full word of space to store the value 4, like this. In single quotes we have to give. So this is the syntax, and also this is the way to declare the value inside the assembly language. So this one we can see in fifth example. We have this thing only. Okay, so symbolic operands means we are using symbols. Which one we are dealing as a symbol? FOE is a symbol. FOE is a symbol. That is it to be symbolic operand. Operand means that value 4 is an operand, right? Okay, clear. So let me clear the screen. Next one, data declaration. The same example I am going to take. What example I have given? FOU DC, which means define constant, and one full word I need to store value 4. Okay, here data declaration, which means I am declaring the 4, okay, declaring the 4 by giving these methods, by giving these formats. Okay, so now the data has been declared here. Okay, data has been declared here, and by using define constant, this the pseudo code, I have declared the data. Okay, so this is the thing for data declaration. So in this way we can declare. In symbolic operand we have concentrate on FOU. This is symbolic operand, and data declaration means that is the 4. We have to declare like this. Okay, if you want to define any constant, want to declare any constant, we have to use in this method. Okay, I am clear the screen. Next we have and its description we have here. So by using examples we have learned that. So what is data declaration here? Data can be declared in variety of notations, including the decimal notations. Okay, variety of notations means we can say we are storing any variable. The variable name can be anything. For example, FAC. Okay, FAC, face. Okay, face 1, like this also we can give variable name. So this is said to be decimal notation. This is said to be decimal notation. This is said to be symbolic operand, right? Symbolic operand. So symbolic operand we can say. See, variety of notation means we are using different patterns here, which means the decimals we are taking letters, some letters we are taking from alphabets. That's why it's saying that variety of notations we can define the data. Okay, we can define the data. Next we will come to middle of your screen. So that is pseudo op. Okay, pseudo op. So pseudo op, what it is? Pseudo op means already we have seen it is going to give instructions to the assemblers. It is going to give the instruction to the assemblers. So first we will talk about using. So using I am given here. So pseudo op, it is a pseudo op that indicates to the assembler which general purpose register, okay, to use as a base register and what its content will be. See, we have general purpose register in IBM 360 from R0 to R0 to R15. We have 16 general purpose register. Okay, so among these, which one we are going to use as a base register? That we have to give instruction to the assembler at the beginning of the program. So this is the syntax. This is the syntax, and this is the way to tell the assembler that I am going to use the register 5 as a base register. Okay, by using this pseudo op. So using star comma 5. So here 5 specifies the base register. The 5 register number 5 I am going to use as a base register, and the star specifies the current address of the location. Current address of the location, which means we know that core memory has many locations, right? Many locations. In previous examples and all we have seen, we have taken absolute address, relative address and base address. We will find absolute address. That address we will take, right? To find out anything, to find out operand or instruction which we have stored in core memory. But here what you are going to do, we are going to store the current location of the core memory, which means the current location of the instructions into the base register. So when the first instruction is executing, after then the second instruction is going to execute, right? So after executing the first instruction, the second instruction will be placed in base register. That address will be pasted into the register. So when the second instruction has been executed, the third location address will be given to the base register. So the address is going to change continuously, okay, which means if you are given star, it will take the current location of the instruction. Okay, so when we are dealing with program, that time we will clearly understood this thing. Okay, no need to bother about this. So I have two examples here. The first we have seen, the second one is using begin plus 15, which means 15 is the register. We are telling the assembler I am going to use the register number 15 as a base register, and begin is a label. Begin is a label. If you are giving this label, the program is going to begin plus 2. Plus 2 means 2 bytes we have to leave location. 2 bytes we have to leave location. After then we have to start the execution. Okay. After this we have to start the execution. See, one more thing I want to include here. This 8 pseudo ops is just going to give the information to the assembler. It is not going to execute inside the assembler. It is just a directives. That's why I have given here. It is an assembly directives. Okay, we can say this is an assembly directives and also pseudo ops. Both are same. Okay. So next we will start with the pseudo op start. So the pseudo op start tells us the assembler where the beginning of the program is, and it allows the user to give a name to the program. So I have some examples here. So here test is the name of the program and start is the pseudo code pseudo op which tells the assembler to start from this location. Okay, so here we are not going to specify any locations. Okay, just we are giving test start. Okay, test means program name. Here test is the program name and start is the pseudo op, and similarly John is the program name and start is the pseudo op. Okay, that thing only I have given here. This is nothing. This one we can understand easily. Okay, in this way we can give the start pseudo op. And next one is end. End means we are telling the assembler that where the program is going to end, which means that tells the last statement of the program has been reached. Which one? The end pseudo op will tells the assembler like this. Okay. Next we have EQU, that is equivalent. See, in C programming we have seen that we may know that. So what we will do to define macros preprocessors. So hash define, in the header we will define like this, hash define. Okay, so pi, for example, pi, take one variable like this. Okay, equal to 3.14. So wherever I am giving pi inside the program, so that will be substituted by the value 3.14, right? The same thing only going to happen in this equivalent, which means you see the example. Here I have 15, right? Here I have 15 and pseudo op, that is EQU, and the base is the variable name, and also base we can call it as symbolic name. So here we should not call it as a variable name, we have to call it as symbolic name. Okay, so base is equivalent to 15. Here 15 is the value. Okay, 15 is the value. So wherever I am giving base inside the program, the word base, wherever I am typing inside the program, it will assume that it will replace the value 15 instead of base. It will substitute the value 15 instead of base. This is the meaning of this equivalent. Okay, so in this example, two examples I have given here. The first one is base equivalent to 15. The second one is index equivalent to 5. So wherever I am giving index inside the program, the word index I am giving inside the program, it will be evaluated as 5, which means 5 will be substituted instead of index. Okay. Fifth one, we have DC, right? DC already we have seen what it is. DC stands for define constant. So we have here define constant. So it is a pseudo op used to create memory area to hold a constant value. It constructs memory words containing. What it means? So already we have seen that example. Again I'm going to explain this. See, in this example, 4 is the word, that is symbolic name. Variable name, symbolic name, both are same. But when you are dealing with assembly language, we have to say this is symbolic name. DC is the pseudo op. F is the full word. Full word, how much it is? 32 bits or 4 bytes we can say. 4 bytes of memory is going to allocate for the value 4. Okay. And here we have 1. So 1 is the symbolic name. In this 1 we are going to store the value 1. Okay. So DC is the pseudo op. F is the full word, which means 4 bytes will be allocated for the value 1. Okay, this means this one. So this is define constant. Next one we have define storage. Define storage. So how to define storage? So it reserves some storage for the data and give them a name. Okay, we will see what it will be. See, here I have example block TS5F, which means block is the name of the space which we are going to allocate. Space which we are going to allocate. What is the name stands for? Define storage, right? We are defining the storage. So name I am giving here block. Okay, block. Okay, how much storage we need? 5F. 5F means 5 full words I need. 5 full words I need. So 1 full words is equal to 4 bytes, right? 4 bytes, 32 bits. 1 full word is equal to 4 bytes. So we have to specify bytes in capital letter. Okay. So 4 into 5 we will get 20 bytes. So 20 bytes of memory we are going to allocate. Okay, according to this instruction, 20 bytes we are going to allocate for the variable name, symbolic name, block. For block. Okay, similarly in second example also same thing only we are going to do here. Here I have A as a symbolic name and DS is the pseudo op. So 1F is the memory which we are going to allocate for this variable name or symbolic name A. See, again I am telling you we have to say this thing as a symbolic name only. We should not say that is a variable name. For our understanding I am telling this. Okay, hereafter I am not going to use a variable name, right? Okay, only symbolic name I am going to specify here. Okay, so what it means, in the name of A, symbolic name A, I am going to allocate 1 full word inside the core memory. Okay, inside I am not going to store. See, inside I am not going to store. Here I am not storing anything inside, just I am allocating storage for the given symbolic name. Okay, so if you are using DS, which means define constant, sorry, define storage. Okay, here next one we have drop. See, in drop specifies that the unavailability of base register. See how we will understand this. See here, as per the example, drop 15. Here the 15 is the register. For example, here we have chosen the 15th register as a base register, right? So we are telling the assembler that 15th register is unavailable by using this pseudo op. If you are giving drop 15 means the drop 15 is unavailable currently. Okay, we are telling the assembler so that that register will not be no more, right? Here we have LTORG. So LTORG means organizing the literals. So here literals means nothing, datas, operands. Okay, literals means datas or operands which we are using to do some operation in the program. So data is the main thing, right? So we know that our core memory setup will be like this only, right? So here we have instructions on top. Okay, instruction will be on top. So when the instruction is over and the immediate after location, we need to start literals. Literals means operands we are going to store here. Okay, operands we are going to store here. In every example we have seen that operands we have stored after the instructions, program instructions, we have stored operands. But we are going to give here ltorg is a pseudo op that we are going to give after the instructions, which means we are telling the assembler that in this way that we have operands after these instructions by specifying this pseudo op. Okay, that is the meaning of this ltorg. Ltorg means organizing, org means organizing, lt means literals, so organizing the literals. So what it tells the assembler to place the encountered literals at an earlier location after instruction. Okay, that only we have seen here. Okay, so in this presentation we have learned what is pseudo op. So in upcoming classes we will see about machine op. Okay.